I'm going to talk a little bit about how we get to develop a PKI, or public key infrastructure, in minutes, not months. That's the way it's been done before. So I'll start off by talking a little bit about who DigiCert is, because I don't think it's a household name that you're familiar with. I'll just briefly talk about what PKI is and how PKI is used, and why we use a cloud PKI in today's architecture, and how we got there in minutes, not months, and how you can set up a PKI in minutes, not months. And then I was going to talk about some PKI market stats, but those didn't make it into the presentation. So instead, I have a very geeky video on cloud engineering from our chief architect that I'll show you. OK, so who is DigiCert? You probably are not familiar with it. It's not a household name, but you probably know the name VeriSign. VeriSign was established in 1995 as the first commercial public key infrastructure provider. And that company provided certificates mostly for websites, SSL certificates, now known as TLS certificates. That company grew from 1995 until 2010, when they sold the PKI business to Symantec. And Symantec had that business from 2010 to 2017, and then that business was sold to DigiCert. DigiCert was a smaller PKI provider that was established in 2003. But now, with the acquisition of that VeriSign and Symantec PKI business, we are now the largest commercial public PKI provider in the world. We have offices in over 180, we have customers in over 180 countries and offices all around the world to support PKI users wherever they might be. So what do we do with PKI? Well, there are 4 principles that are enabled with PKI. The first one is privacy. We want to make sure that you and I can communicate without a third party listening to that communication. The second is authentication. We want to make sure that I am reading the message from the person who I believe it really is, and I have a high confidence that it is that person. The third is integrity. I want to make sure that the message I'm receiving has not been tampered with. And the fourth is non-repudiation, meaning that the person that sent that message cannot deny that they sent that message. So those 4 properties are enabled with public key infrastructure, and specifically 2 technologies: encryption and digital signatures. Privacy, obviously, with encryption. Authentication, integrity, and non-repudiation with digital signatures. So what goes into a PKI? Obviously, we need to validate and register participants in the PKI so that we know who they are. And then we can issue them credentials, and this is all based on public key cryptography, which was established in the 70s. So in a PKI, there are several components. Obviously, the certificate authority is the independent third party that verifies the identity of the individual or the entity, and then can issue the certificate using a registration authority. In the case of emails, where we're sending emails between 2 parties, both parties need certificates. If I want to send you an email, I need your public key. I take your public key, I encrypt that email, and then only you can open it with your private key. The same thing if you want to send something to me. I give you my public key, you encrypt it with my public key, and then only I can read that email. So that all happens because of what's available from a PKI and a certificate authority. So there are many use cases for PKI out there in the world. Probably the best known is SSL for websites. There are many, many websites out there that use SSL today, and I'll give you one statistic a little bit later on. But that is enabled with public trust and a fully managed PKI. Then you have probably the next big leap in PKI use cases is IoT. Think about all the IoT devices out there on the planet today, whether it's baby monitors and cameras and thermostats, or industrial IoT devices and automobiles. All of these use cases do require the use of certificates to ensure that they are communicating securely with other devices. When cars communicate, you want to make sure that that communication is secure and that no one can inject a message in that communication path. And then there are a lot of government programs. You heard about FedRAMP just now. But there are other government programs, not just in the US, but also around the world, where they need things like key sovereignty, making sure that data doesn't leave or keys don't leave that country. And then we have secure mail. Now, here's something that's really amazing. Secure mail has actually been in use since 1996, or maybe even before that. But until this month, there has never been a standard for how secure mail has been sent and received. VeriSign had established this program where they had Class 1, Class 2, Class 3, SMIME, or secure mail certificates. And that sort of became a de facto standard. But no one had actually documented that into a formal standard. Well, on September 1st of this year, the CA Browser Forum released the standard for SMIME certificates. And so now you have a universal standard that can be used by mailbox providers and certificate authorities for issuing those certificates. And probably the last use case, which I'll highlight here, is something that happens every day, but you probably don't see it or you're not exposed to it unless you're a developer or maybe a user, is code signing. When you download code from the internet, usually you get a little pop-up message that says, do you want to trust this code from this source signed by this certificate authority? That's probably the most visible aspect of code signing. But what actually happens in the background, when you look at a company like Microsoft or Adobe, they're constantly signing their code as they build it. So in the CI/CD pipeline, they're signing code every night, every day, so that the next day when they come in, they can get that code and verify that that code has not been tampered with and that it is authentic. I was talking to somebody from Microsoft earlier, and they told me that they do over 1 billion code signings per day. So imagine a big company like Microsoft signing all their code constantly, over 1 billion signings a day. So how was PKI deployed in the past? If you were around like me in the early 2000s and late 90s, in many cases there were companies that said, hey, you need to own that PKI. You need to run it yourself. Here's our CD with our PKI software. Go get your Oracle license, go get your hardware security module, and run it in your data center. And there were companies like Baltimore Technologies and Entrust that really pushed that model. And then you had companies like VeriSign that were pushing a classically architected solution that basically said, we're going to do a managed PKI for you. You don't need anything on site. We'll manage it for you. We'll give you access. So those were the solutions that we had in the past, but not everybody, that didn't fit for everybody. Not everybody wanted a fully managed PKI. And believe me, not everybody wanted to do it themselves. That was a very, very difficult and very expensive undertaking for most parties. You needed expertise, you needed consultants, you needed a certificate practice statement. Just a lot of things that just didn't make sense for most organizations, unless you were a big government entity or a huge company. So what we decided to do at DigiCert was develop a cloud-native PKI architecture to meet these goals. And as you can see, the goals are things like reducing support costs, getting things to market more quickly, being compliant, serving new markets and customers like IoT, and really creating a platform that's going to grow for the future. So no need to install it yourself on site, no need for a managed PKI, a cloud-native architecture that can be installed in the cloud, in your cloud, a hybrid cloud, whatever. So look at the classical deployment, right? We look at, you got to buy hardware, you got to buy all this hardware, you need third-party licenses, you need a lot of licenses, and you need all these skills to actually deploy the PKI. And contrast that today with the modern architecture, which basically says all of this now sits in the cloud. So you don't need any hardware, you don't need any software, you need one license for the cloud, and maybe a little bit of skills to help set that up. If you don't have them, we can help you or somebody can help you. So now we're going from months of configuration work to hours or minutes of configuration work. And this is something that we really strived to pull together for making public key infrastructure easy to use, because the key word in public key infrastructure is the last word, infrastructure. People plug in their computers and they expect them to work, they expect them to connect to the internet, and in many companies they expect them to get certificates for use in secure email, for authentication and other purposes. One of our clients at IBM, they talk about how when they get a new user on board, they plug that computer into the internet and suddenly certificates are automatically procured for that system and for that user. So it's really just part of regular infrastructure, power, internet, and PKI. So we used the 4 native cloud architectures here to develop this system, the CI/CD pipeline, the DevOps, the microservices, and the containers to make this all work together. And we'll talk a little bit about how each of these plays in this architecture. So look at DevOps. You know, in the past, we had silos of developers out there. Everything was done manually. Teams were focused on components, and this was very slow to change, and when we wanted to add features, it took a long time. Now, with DevOps, we work in a collaborative environment. Our processes are more automated. We're focused on the product with cross-functional teams, and this allows us to rapidly add new features as they are requested or as they are needed. And all the servers are now standardized. So this is a huge help in developing this cloud architecture. Of course, we can't talk about cloud without containers. Back then, development had a different system than production. And we can say, hey, it works on my machine, so it must work. It was very slow to get things started and really inefficient in terms of how resources were used, and it was very expensive. And contrast that with how we work with containers today, where the production environment is actually part of our development environment. And it actually works on my machine and in the production machine. It gets executed immediately, And now we can optimize our resources in a more cost-effective way. And when we look at the services architecture part of this, in the past, limited reuse and very difficult to integrate, was not easy to scale, very rigid, very disruptive, and it was a very fixed deployment, as opposed to today, where we have an API-driven, easy integration architecture. It's scalable horizontally. We can develop services in isolation, and a very flexible deployment model. And then, of course, CI/CD, the pipeline here. In the past, everything was done manually. We didn't get a lot of feedback from developers. It was very slow. Changes were huge, and we had a lot of long maintenance windows. And contrast that with today, where feedback comes very, very quickly. The processes are repeatable and automated, and we really don't have much downtime. So things have improved dramatically with the use of the cloud-native technologies. OK, so I have a short video to show you. This is where I told you it's going to get a little geeky, but this was done by our chief architect. And I'm not sure if this is going to work, but I hope it does. There it is.
DigiCert 1 can be installed in minutes versus months. Our modern PKI platform was engineered for the cloud. Before starting, let's assume you have access to a Kubernetes cluster. This cluster can either be in your data center, or it can be a platform on a cloud provider. Additionally, this cluster will need access to an email server, a database service, and an HSM. Although the HSM is not required for initial setup, it can be added at a later time. Let's give a brief overview of the Kubernetes system. What is Kubernetes? Kubernetes is a container orchestration system installed on a collection of master and worker nodes. Generally, these nodes are Linux virtual machines capable of running a Docker engine. These services work in a unified platform to simplify the management of containerized applications. We had the goal to build a flexible system that was easy to scale and highly available. That is why we chose to build DigiCert 1 on Kubernetes. With simple commands, Kubernetes can automate the rollout of new features, secrets and configuration management, service discovery, network load balancing, and self-healing of failed services. In short, Kubernetes is a tool necessary to deploy, install, and run cloud-native applications such as our DigiCert 1 modern platform. To install DigiCert 1, you need to install and download a few tools on a deployment machine. This machine can be a laptop or any system that has network access to your Kubernetes cluster. All these tools work on Mac, Windows, or Linux. So the first thing we need to do is install the Kubernetes command line tool on the deployment machine, or kubectl for short. kubectl is the main way you interact with your Kubernetes cluster. This tool is able to deploy applications, inspect and manage cluster resources, and view logs through command line arguments or declarative YAML files. These management actions are made through authenticated API calls to a master node in your cluster. Kubernetes supports multiple authentication methods, from basic username and password to client-server authentication. So the next thing to install on the deployment machine is Helm. What is it? Helm is a package management system. Most operating systems and programming ecosystems have a package management tool. Linux has Yum, Java has Gradle, and Kubernetes has Helm. It defines the application configuration, container information, and deployment information in a collection of files called Helm charts. DigiCert 1 Docker containers are stored in a Docker registry, and charts are stored in a DigiCert Helm chart repository. So the last step is to install the DigiCert 1 configuration management tool, dcone. This tool is responsible for collecting environment information needed during the DigiCert 1 installation. It collects information such as email server configuration strings, database configuration strings, and HSM information. This tool outputs YAML configuration files that will be used by Helm and kubectl during the DigiCert 1 installation. Now we have all the tools installed. Let's start by running the installation commands. Run the dcone config command and enter the correct values when prompted. When this tool completes, it will output files used for the DigiCert 1 installation. It is important to store the dcone secrets and dcone deployment values YAML in a secure location. These files can be used to restore your DigiCert 1 system if needed. So the next couple of commands will configure the database and deployment tools for the final installation steps. Start by having your database administrator run the SQL script against your database to create the DigiCert 1 schema. Next, configure the Helm tool to point to the DigiCert chart repository. All that is left is to run a few simple kubectl and Helm commands to configure the Kubernetes cluster and install the DigiCert 1 containers. And now, in a matter of minutes, you can use your DigiCert 1 system.
All right, I told you it was going to be a little geeky, but I should also tell you that it's not that complicated to install DigiCert 1. Most of that is done for you in the background. I just thought I would give you a little bit more detail for those of you that are interested in how that works. This video is available on YouTube if you want to see it. I just noticed that at the end when he had that white box and he was talking about commands, normally you will see in that white box the actual screen of the commands. I'm not sure why it didn't show up here. All right, so now that we've got this development of a cloud-based PKI, we have a very comprehensive digital trust fabric. And what do I mean by that? So when you're deploying certificates nowadays, especially for SSL, you know, when I started in this industry, SSL certificates were good for 5 years. Then they were reduced to 3 years, and then 2 years, and now they're valid for only 1 year. And now there's talk about making them valid only for 90 days. How are you going to manage certificates that are only good for 90 days if you have hundreds or thousands of certificates in your environment? And the only way you're going to be able to do this is through automation. You have to have automation to be able to go out, see when those certificates expire, request new certificates, and issue those certificates without human intervention. You also want to know what certificates are running in your environment. And so you need a system that will do discovery, online discovery of every certificate type that you have, whether it's from DigiCert, Entrust, Sectigo, GlobalSign, whoever it is. We want to be able to find those certificates, inventory those certificates, find out what algorithms they're running. We heard earlier today about post-quantum cryptography. What if we have to replace certificates that currently have RSA cryptography with PQC certificates? We need to identify them, find out when they expire, and automatically reissue them. And all this can be done with a comprehensive digital trust fabric. So it's important to do this not only for SSL, but for things like devices, software, content, and DNS. All of these applications for certificates are real use cases that we see in people's environments today. So to summarize what I've been talking about, look, we had to reinvent PKI. Nobody wants to deploy it on-site with hardware, with Oracle licenses, with HSMs. They want it done for somebody else that can do it as an infrastructure. So what did we do to make this happen? We drove out the cost and the complexity of doing it. We moved from physical services to the containers in a cloud environment, got rid of the complex network configuration, moved it into Kubernetes, and got rid of that complex installation to a CI/CD installation. So now we've got a single architecture that's repeatable, but it can also be customized for your own needs. And this helps us deliver the world's most advanced PKI platform. We do have a booth out here today, so I invite you to stop by if you wanted to learn more about this. And again, if you have used PKI or are new to PKI, we'd love to talk to you more about this situation. So we have like 30 seconds for any questions that might come up, and be happy to address those.